It is the image of the man-made world, the flesh of just about every consumer good. But what really is plastic? First we can examine the unintuitive source, fossil fuels. Of course, fossil fuels are seen mostly as the energy source of civilization. However, the impact is even more far-reaching. This means that from dead organisms many years ancient, once full of natural life, comes the very man-made plastic. Somewhat ironic, fossil fuels provide a sufficient chemical structure to undergo petrochemical processes which are used. The desired output is the polymerization of the monomer materials. Polymers consist of very large molecules, and all sorts of interesting things can be done with them. Manipulations can turn normal materials into seemingly alien creations. This is the amazing thing about plastics. The glossy finish is able to be produced, the clear building material it can provide, the variation in strength, structure, function. Polymerization combines many small molecules into a covalently bonded chain or network. Synthetic methods are generally divided into two categories: step growth and chain polymerization. The key difference between the two is that in chain polymerization, monomers are added to the chain one at a time. Chains of monomers in step growth can combine with one another directly. Polymers also have a range of microstructures which affect its properties. Some are linear while others are branched, semi-crystalline, slightly or highly cross-linked. The plastics formed by these different structures also have different indexes of refraction. IA determines the behavior of light interacting with the given material. Designing the visual aspect of a product considers the index of refraction to create the desired look of the object. Some of the most common plastics are polyethylene terephthalate, high-density polyethylene, polyvinyl chloride, low-density polyethylene, polypropylene, and polystyrene, due to their respective properties. In engineering or other applications in which intense stress are inflicted, properties like heat resistance or water resistance are considered. Specific monomer chains are designed for this purpose. Some engineering plastics include acrylonitrile butadiene styrene, nylon 6, polyamides, polyetherethyrketon, and polyphenylene oxide. Polyethylene terephthalate is produced from ethylene glycol and dimethyl terephthalate, but mostly terephthalic acid. Ethylene glycol is made from ethene found in natural gas, while terephthalic acid comes from p-xylene made from crude oil. Typically, an antimony or titanium compound is used as a catalyst, a phosphite is added as a stabilizer, and a blurring agent such as cobalt is added to mask any yellowing. Polyvinyl chloride is produced by the polymerization of the vinyl chloride monomer. About 80% of production involves suspension polymerization. Emulsion polymerization accounts for about 12%, and bulk polymerization accounts for 8%. Polypropylene is produced by the chain growth polymerization of propene. The industrial processes can be grouped into gas phase polymerization, bulk polymerization, and slurry polymerization. Cutting-edge processes use either gas phase or bulk reactor systems. Polystyrene is an addition polymer that results when styrene monomers polymerize. Through compounding, plastics can be mixed with additives to create even more complex materials. This can be seen through the addition of strength components such as fiberglass. Antioxidants, UV stabilizers, and other value-adding agents can be incorporated as well. Styrofoam is an interesting creation used for a variety of packaging applications. It has a strange puffy cloud-like texture which can serve as protection for things inside it. It leaves a huge amount of space inside it for air. Styrofoam is used in buildings, blocks, and even in roadways. It is a type of extruded polystyrene or XPS. Much of the world's piping is done using PVC. PVC has chemical-resistant properties this industry finds favorable and uses it in both solar and home applications. In order to manipulate the substance from its raw form into a commercial good, injection molding can be used. It is simply made molten then injected into a mold. Another method is film blowing, in which a liquid is inflated into a bubble with air. Several other techniques are used as well. Plastics engineer has become a significant job over the years. It can take quite the maneuvering to optimize performance, quality, and other factors related to the industry. The geometry of these items can drastically change the final output. Special machines can be designed for this. Structural specifications on macro and micro scales are important and vary from piece to piece. Connectivity and the way pieces interact with each other to form the complete product are considered. Automation to ease the load on the human workers can have large impacts on financial and logistical factors. Engineering software skill and experience are not to be overlooked. The economics of polymers have been very significant, contributing many billions of dollars. Large enterprises have taken several different forms, from resource extraction to recycling to manufacturing facilities. These companies have also been run by private individuals, governments, etc. They have had real impacts on international relationships and international markets. Plastics were initially developed by three main scientists, one German, one Austrian, one Belgian. In a search for a new item to shake up the market, bakelite was developed. Around the same time, the existence of macromolecules were demonstrated. X-ray diffraction work on the molecular structure of fibers also provided important evidence for the macromolecular theory of polymer structure. Nowadays, roughly 400 million tons of plastic are being produced every year, and thus employing an appropriate human force to create it all. Much of what is being created is repurposed from previous products. It makes somewhat of a plastic cycle similar to the water cycle. Again, drawing comparisons to how humans have created this polymer world in the image of the natural world. There are many stations set up around the world, tasked with the recollection step of the plastic cycle, and of course are then passed off to the following steps. New forms of plastic are frequently being tested and discussed. There's also been much consideration into replacements for plastic. Different forms of metals have been considered as to provide metallic structural strength. One new supposed wonder material which was brought up quite often in recent years was graphene, due to its electrical conductivity, tensile strength, transparency, and thinness. Not only has plastic proved to be a useful material, it has created entire new categories of products. Categories which would never have been conceived without plastic. It has served as the aesthetic for a technologically advanced society and defines the way humanity sees itself.